Balancing easy redox reactions. Example: the following is a simple redox reaction that could be balanced easily using the methods from the last quiz. We will use this easy example to illustrate how to balance a redox reaction using the electron transfer half reaction. You can just balance it as we did before, but we're just going to use this simple example. The example below is a single replacement reaction. All single replacement reactions are redox reactions. We have aluminum plus gold 1 nitrate. And the reason why I know it's gold 1 nitrate is nitrate is a minus 1. Therefore, gold must be plus 1 because a compound, the oxidation numbers add to be 0. It forms aluminum nitrate plus gold. First, assign oxidation numbers to each element in the compound using the oxidation number rules. Note in a compound with 2 or more elements, for example, the aluminum nitrate, the oxidation number of the element in the middle, in this case it's nitrogen, is often different from the oxidation number used in the columns in the periodic table. Aluminum is an element by itself, therefore it's 0. Gold is an element by itself, therefore it is 0. Gold is a plus 1 because nitrate's a minus 1. And you have to have 3 nitrates on the right side of the equation because aluminum is a plus 3, nitrate's a minus 1. A plus 1 and a minus 1 is 0. A plus 3, 3 times a minus 1 is a minus 3. This is equal to 0. In redox reactions, however, we have to look at each individual element. So we know that the gold is plus 1, the oxygen is a minus 2. The one in the middle, the nitrogen, can change. 3 times a minus 2 is a minus 6. A positive 1 and a plus 5 is equal to a negative 6, which is 0. On the other side, again, we need to do each element. And we're looking at the one in the middle can change. Aluminum is a plus 3 from the columns. Oxygen's a minus 2. 3 times a minus 2 is a minus 6 times 3 is a minus 18. So we have a positive 3 from the aluminum and a minus 18 from the oxygen. We have to have a positive 15 for the nitrogen. And there are 3 times 1, 3 of them. So each nitrogen is a plus 5. So we're going to be looking at the individual element. Look for the 2 elements with a different oxidation number on either side of the arrow. There will be only 2 elements that change. If you have more than 2, you've done something wrong. Go back and look at your oxidation numbers. One element will become more positive, oxidized. One element will become more negative, reduced. Chemical reactions involve the transfer or sharing of electrons. Thus, the method we will use is the electron transfer half reaction method. The 2 elements that change oxidation state are aluminum and gold. Aluminum is 0 on the left and a positive 3 on the right. Gold is 1 on the left and 0 on the right. Make 2 and only 2 half reactions. Because only 2 elements change, there's only going to be 2 half reactions, showing the electrons changing from one side to the other. Aluminum went from 0 to positive 3. Gold went from 1 to 0. So aluminum went from 0 to 3, and the arrow acts as an equality. So how can you get from 0 to 3? You have to add 3 negatives. 3 negatives and 3 positives is 0. You put the electrons on the more positive side of the arrow. Gold went from 1 to 0, so positive 1 and negative 1 is 0. Notice my electron change is not the same, so that's what we're going to look at in the next slide. To get this electron change the same, if we multiply this half reaction by 3, that means that we will have 3 electrons on both half reactions. That's what we're looking for. And you notice to do that, we had to have 3 goals on either side. In this case, the electron change is now equal. Sometimes it won't be. In that case, you would do the least common multiple. Use the coefficients. I had to have a 3 here and a 3 here. So place those coefficients you found in your half reactions back up in the equation. So I put a 3 in front of the gold here and a 3 in front of the gold here. In other words, you balance the half reactions and you use those numbers to balance the whole reaction. Check to ensure the equation is balanced. You may have to adjust the coefficients of the other elements or compounds to balance the equation. Sometimes you must change the coefficients, for example, this 3 and this 3, that you found balancing the half reactions. You may go above the numbers found in balancing the half reactions, but not less than the numbers found. To balance, do metals first, nonmetals, polyatomic ions, hydrogen next to last, and oxygen last. If you will follow this rule, in general, the equations will balance very easily. So we check. I have 1 aluminum on the left, 1 aluminum on the right. I have 3 gold atoms on the left, 3 gold atoms on the right. Notice my nitrate group stayed together. So for ease of balancing, I'm going to keep it together. I have 3 times 1 is 3 nitrates on the left and 3 nitrates on the right. The equation is balanced.